Excellence for simultaneous equations at year 12. This line crosses the parabola at two places. Those are the two solutions to my simultaneous equations up above. This line crosses the circle in two places, but this line doesn't. So what values mean that the line and the circle, or the line and the parabola, do not intersect? At excellence, you would be asked to change any one of the coefficients in front of the y's or the constant to determine at what point they will intersect and what point they won't. So I'm going to do it for the simplest case, but all the others are done exactly the same way. We substitute out one of the variables. So in this case, easiest way is to substitute y for y. So 2x plus k equals x squared plus 3. We do what we always do, and then we do the same as we always do. We rewrite it in the form ax squared plus bx plus c equals 0. Then we recall that the numbers of solutions of quadratics is determined by the discriminant being b squared minus 4ac. So in this case, we take the discriminant, the coefficient in front of the x, which is our b, square it, 4 times the coefficient in front of the x squared, and then the constant c is all of 3 minus k, so it gets substituted in brackets. We expand very carefully, and then if we want, say, the purple line, which is our tangent, the discriminant is equal to 0. That solves to k equals 2, and then it would be extremely wise to go and actually make sure it's true. In this case, k is in fact going to give an intersect of 2, y equals mx plus c, so graphically it checks out fine. With circles, the same procedure applies. B squared minus 4ac equals 0 yields a tangent, but there are two tangents. There's going to be one at the bottom here and one at the top here. B squared minus 4ac is greater than 0 gives two solutions. That's going to be a range between the two tangent ones, and if it doesn't intersect, b squared minus 4ac is less than 0, and that's going to be above this point and below that point. That's basically all you need to do. We solve as normal, and then we check that the discriminant is greater than, less than, or equal to 0.